This is Wendy, and in this video series, we're learning the basics of OOP, or Object-Oriented Programming. In the first video, we had an overview of OOP and learned some of the terminology of object-oriented programming. In the second video, we learned how to use classes and objects. In the third video, we looked at how to discover what classes can do by reading the API documentation. In the previous video, we demonstrated how objects and reference variables are stored in memory, and in this last video, we'll learn about objects as method arguments. In the previous video, we talked about how objects and reference variables work in memory. Now that we understand this, we can understand what happens when we pass objects into methods. First, let's discuss the idea of pass by value. When you pass a primitive variable into a method, you're passing a copy of that value to the parameter variable. For example, in this code, I'm creating the integer variable num, which has a value of 5. Then I pass num into a method I just called method. Inside method, I receive that value as the parameter variable n. I print n, change it to 2, and then print n again. And then when I exit the method and return to my main, I print the value of num. Let's see what the output will be. So notice the output of this program is 5, 2, and 5. So again, when I passed num into my method, so it landed in the parameter variable n. So my first line of output is this one, and that prints the value 5. That should have been easy to guess because we passed a 5 into that. Then I changed the value of n to 2. So when I print it after that, of course, I'm going to get the output 2. When I come back to my calling program, which is my main method, I then want to print the value inside num after the method is executed, and you'll see that it has printed the value 5. That implies that when I passed num into the parameter variable n, and then I changed n, that had no effect on the original variable num. The parameter variable n actually took a copy of the value inside num and changed the copy, not the original variable num. We can trace this code manually and you'll see what I mean. So I start off by executing the code in my main method. So the first thing I do is in my main, again, when we're working with methods, we want to make sure we keep the memory areas separate. So in my main, I'm creating a variable called num and I'm initializing it to 5. Then I invoke method and pass it num. Inside method, I'm going to put the memory for method here. In this area. Inside method, there's a parameter variable called n. I'm going to take a copy of the value in num and pass it to n. So that's going to take a copy of the 5. So it's a copy, not the original. Then inside my method, I print the current value of n. We look up n, it has a value of 5. So I print 5. Then I take n, and I'm changing it to 2. So I take n, and now it has a value of 2. It's this variable n here that I'm editing. Then I go and print the current value of n again. I look it up. It has a value of 2, so I print 2 on the screen. When I'm finished, I then return back up to my, whoops, it went off the screen, back up to my main method and move on with the rest of my program. I now print num. When we look up num, we're in the main method. So we're looking in this area of memory. There's the variable num. It has a value of 5. So that's why it outputs 5. So this is often called pass by value. You're basically taking a copy of the num value and you're passing the copy into the method. That way, when you modify the parameter, it is not affecting the original variable. So pass by value. But how does this work with objects? When you pass an object to a method's parameter variable, what is it passing? Many programmers will tell you that in Java, objects are passed by reference. In other words, the reference or pointer to the object is passed to the method, which has the effect of passing the original object to the method and not a copy of the object. Let's try this in a demo. So in this program, I'm constructing a new cat object called cat1, and I am initializing this cat object with a name of Artie and a breed of Tawny Tabby. Then I invoke method and I pass it the cat1 object. When I return from that method, I then print cat1's info. The method itself, it's accepting a cat object into the parameter C. I am then changing the name member of that C object to kitty, and then I'm printing that cat object's cat info. So we can probably guess that inside the method, cat info is going to print a cat object with the name kitty, but the breed tawny tabby. However, what's going to output after the method executes when we print cat1 info? Is it going to print a cat with Artie, or is it going to print a cat with kitty? Let's find out. So we can see by the output, my first line of output is inside the method where it prints a cat with the name of kitty and the breed tawny tabby, because we did in the method change the cat object, the parameter cat object, we changed its name to kitty. But notice that the second line of output also prints a cat with the name kitty. So what this seems to imply is that when we construct an object in the main and then pass that object into the method, and then the method modifies that cat object, unlike primitive variables, it does affect the original object, because cat1 cat info didn't print Artie, it printed kitty. If we were to trace this code to see what's actually happening, it's actually quite simple. In the main, when we create the variable cat1, remember, that's creating a variable in the stack area of memory. In the heap area of memory is where it's actually constructing the actual cat object with a name set to Artie, and the breed is set to Tawny Tabby. I'm going to abbreviate that in the interest of space. And then the address, let's say it's at address FF88, the address of that variable ends up inside the cat1 variable, just like that in the stack. So now when we invoke method and we pass cat1's value into the parameter C, so if this is my main area of memory, we'll put the method area of memory down here. So we have this variable in the stack called C, and what's being passed in from here to here, it's actually passing this memory address. So it's passing FF88 into C, which means not only is cat1 pointing to this cat object in memory, so is C. It's also pointing to this cat object in memory. That means when we invoke C.setName and pass it the argument kitty, it goes and looks up C, sees that it's pointing to FF88, so it goes to FF88 in memory and sees this cat object. It goes to the name, because we invoked setName, and this is what setName does. It goes to the name, changes it to kitty instead, and then returns back to the method where it now prints cat info. So this is going to print a cat with the name kitty and the breed Tawny Tabby, etc. Then when we're finished, we go back up to the calling program and continue. We now print cat1.catInfo. So we go look up cat1, it's pointing to the address FF88. So we go to that object and we look up the information, name kitty, breed Tawny Tabby, and we print that to the output. So kitty followed by Tawny Tabby. And that's why we actually get the same output. These two variables, the original variable in main and the parameter variable in method, are actually pointing to the same object in memory. So does Java pass primitives by value and objects by reference? That's somewhat correct, but technically Java passes everything by value. It just so happens that an object contains a reference or a memory address as its value. So when you pass an object to a method, you're passing the value of that variable, which is a memory reference. So technically both are true. Now, does this also work with strings? After all, strings are objects too, right? Well, let's see with a demo. So in this sample bit of code, inside my main, I'm constructing a string object with the initial value of hello. Then I'm passing that string object into method. And then after the method is finished, I print the string object. Inside method, I'm receiving the string object into the parameter variable s. And then I'm changing s by assigning it a new value, and then I'm printing s on the screen. This is almost the exact same code as the cat example, except that I'm using strings and not cats. So we know that when I pass string 1 into S and we change S to foo, we know that it's going to print foo inside the method. The question then is, what is going to be printed when, after the method executes, I print str1 or string 1? When you save, compile, and execute, you'll notice that you get foo and then hello. So the print line statement in main after the method executes, where we change the parameter value, is in fact printing the original string hello. Well, why is that happening? We just talked about how objects, when you pass them into methods, it's passing the memory address, not a copy. So here it clearly seems to imply that we've passed a copy of the string variable, because when we modified it inside the method, it did not affect the original. Here's the thing. Remember that strings are immutable. In other words, once a string object is created, you can't change that string object. What's actually happening inside the main method when I create string hello, so again, we'll keep our little labels here. It creates the str1 variable, and then in the heap area of memory, it creates a string object whose value is set to hello. It then takes the address, again, let's just use FF88, of that object and stores that address in str1. So we've done this so many times now, this is easy. We know this is what's happening. Then I take that string object and I pass it into method. Inside method, which I'll do down here, I'm receiving this as a string with the parameter name s. So I'll create the variable s. So what's happening when I pass str1 into the parameter variable s, it is passing the memory address. So s is receiving the memory address FF88. So indeed, s is pointing to that string object in memory. Then here's where things get interesting. I now assign s a new string object foo. Remember, strings are immutable. This does not go to the original string and change hello to foo. That's not allowed with strings in Java. Instead, what it's doing is it's creating a brand new string object in the heap area of memory whose value is foo. And if that string object is stored at address FF02, then it's now removing the old address and assigning the new address of FF02. So now we are no longer pointing to, that was supposed to be scribbled out, that string object. We're now pointing to this new string object. So when we print s, it's looking up this s inside method. It says FF02. It looks it up. It says foo. So it's going to output foo. Then when we finish this method and we return back up to our main, we now print line str1. We go look at str1. It's pointing to FF88, which is hello. So that's why it prints hello on the screen. So they are still passing strings by value or by reference, however you want to look at it. It is still passing the memory address, but when we assign a new string, it actually is constructing a new string object in memory, because strings are immutable. You can't change a string value. You can only create new string objects. So strings are objects, cats are objects. They are both passed the same way. It is technically passed by value, but what it's passing is the value of the variable is a reference. So you could say it's also passed by reference, but it is still passing a memory address. It's just that with string objects, because we can't change strings, it always constructs a new string when you change the parameter. But with objects like the cat object, you can actually change a cat object's data. It's totally fine. It's just the way strings work in memory. So they're still being passed the same way. So now that you have a better understanding of objects and how they're stored in memory and how they're passed to methods, you're on your way to being able to create more modular, reusable, and abstract methods and classes. That's it for this series on understanding object-oriented programming. Thanks for watching.